let's go through a little review. Mariana. When we have an expression just like this, ladies and gentlemen, these problems, when we're going to do multiplication today, multiplication is very similar to what we did last 2 class periods ago. Don't ever do that again. So basically, the theory, if you guys remember 2 class periods ago, what we talked about was basically when you're trying to simplify a rational expression, it's either you're doing ones like 1 and 11 or like 11 there where you apply the rules of exponents, right? But if you have expressions, then we're not going to be applying so much of the rules of exponents all the time, but we're going to be looking into factoring. We have to factor before we can simplify. So when we multiply, that's exactly what I want you guys to do, is to look into what can you factor for each numerator and denominator. All right, Stephen? So I'm going to start here in just the multiply component and say, all right, is there anything I can factor out of x squared minus 6x? Yeah, I can factor out an x. Then I go to x squared minus 36x. I factored an x out of x squared minus 6x. Okay? And actually, let me double check my problem that I chose. Sorry, that's a 36, not a 36x. All right. So the next thing that we're going to do is now we're going to factor x squared minus 36. Now, when I have to factor something, and I only see 2 terms, the main important thing that I'm going to look for is either factoring by the GCF, like I just did, or difference of 2 squares. And if you guys remember, the difference of 2 squares states if you have a square term minus another square term, then the factored form is a minus b times a plus b. So therefore, I can factor x squared minus 36 as x minus 6 times x plus 6. OK? Then over here, I have x plus 6. And over here, I have x squared. Now, again, like we did last class period, if you guys understand, if you guys see this, when we're multiplying these, everything between every product is multiplied, right? I'm not adding or subtracting any of the expressions in the parentheses. They're all multiplication. So since everything is being multiplied by each other, I can divide across multiplication. So therefore, I can divide out the x minus 6 and the x minus 6, because those are going to divide to 1. I can apply the rules of exponents to x over x squared.
How? Well, why?
Well, what's x over x squared? OK? You guys could also look at it just like this. X over x squared, which is x times x. Those divide to 1. You're just left with 1 over x. So if I have an x and this x squared, I divide that out into x. Then you guys can also see my x plus 6 and my x plus 6, those divide to 1 as well. So now the only thing left on my numerator is 1. The only thing left in my denominator is an x to the first power. So my final answer is 1 over x.
Why did you cross out the low x? Why did you cross out the x and the x too?
OK, again, I have x. Please stop. I have.
It cancels out with the x2 and only 1x.
It doesn't cancel it out. X divided by x squared is 1 over x. So that means x is going to be left on the denominator. OK? X over x squared is 1 over x. So therefore, x remains in the denominator. Then we also have to write in the constraints. Since we have the constraints here, we look at this and say, what can x not equal? Well, x cannot equal plus or minus 6, and x cannot equal 0. Because if x was any one of those values, it would make our denominator equal to 0.